Today for lab, like I said, we're just going to be working on problems. I'll be showing you how to solve different problems so you can see examples of that. The end, I will require you to do 2 problems using these papers here. So you should have 2 of these. One of them, you're going to do one that I'm doing, so you just follow along. And then the other one will be one that I'm not doing, that you will be doing on your own. So the first 2 problems are not the one that you're going to be having to turn in. It's the third one I do, and then the one after that. And you can follow along on OneNote if you want to have that. Yes, sir.
Will those that we have to do by ourselves, is that due at the end of class, or will that be due like a regular lab report?
It'll be due like a regular lab report. Okay. So you'll turn in just the two problems.
Okay.
Before I get started, just an announcement about next week to make sure that we are all prepared. Next week, we will be meeting not here, but at Defy Gravity, which is across town. If you can't find a ride, contact me and I will try to work with people to get rides. They want us to be there at 2:15. We have a place reserved. It should be just us from 2:30 to 4:30. And we have an activity, basically, we're going to videotape each one of you jumping as high as you can, record, and then you're going to analyze it and take data at 4 different places on your jump and calculate energies in that period. Otherwise, of course, we'll just have fun jumping on the trampolines and thinking about energy transitions. Now, in preparation for that, you do need to complete the liability waiver. So I put a link on the Moodle page for the liability waiver, so you can just do it online. If you're under 19, then you need a written one and need an adult, because under 19 is not adult in Nebraska, to sign off for it. I think Nathan's the only one under 19. Is there anyone else under 19? Okay, so then we don't have a problem because I can sign for Nathan. Yes, Leslie, I got this in my hand because Leslie came. With the Defy Gravity, if you have socks, please bring them because we'll have to pay an extra like $1.75 for the socks. If you have socks for like Jump Zone, you can bring those too. They will simply exchange your Jump Zone socks for Defy Gravity socks. So if you have socks, please bring them. It'll save us some money. Excuse me?
Specific types of socks? Or
Yes, yes, specific socks. The socks they use on the trampolines. They're basically hospital socks. You know when you're in the hospital and they give you those socks that have extra grip on them? They're basically that. But you have to have their brand, but if you bring in a competitor's, they'll just exchange them. And if you bring in socks that don't fit you, they'll just exchange them for ones that do. So all you have to do is bring in a pair of socks.
It won't be a charge?
There won't be a charge as long as you bring in a pair of jump socks. If you bring in hospital ones, I'm sure they'll say, no. But so if you have questions on that, please contact me. And if you don't have a ride, make sure you let me know. Don't say, I'm going to have to miss lab because I couldn't find a ride. I'll be driving out and there are other people with cars. Sarah.
Is there any pre-lab for the lab?
I've been vacillating on that. There was not one you had to do for today, although I didn't remove it. I need to remove it, otherwise it shows up a great book. But I believe I will have one that will be combining ideas and energy from, I think it's lab 5, or I don't remember the numbers. Ideas and energy from the preceding ones, and then the specific activity from this one. So we'll have a combination of 2 labs that are taking ideas from. But I haven't done it yet, so I will let you know when I have it done. All right, now that DJ is here, we will get started with everybody. Just inform DJ later of all the announcements, right? Yeah, anyone who doesn't have, actually, if you don't have those, we'll probably take a break after me doing a problem or two so you can, breathe, whatever. So you can probably wait till then. But what those sheets have is a standard way of doing a Newton's second law problem, a force problem. Obviously on the exam you don't have it, but having an organized pattern in how you solve the problems will really help you to make sure that you don't forget something or you do something incorrectly. So I'm going to start right in. With the problem number 2 here. It's noted that when a 100 kilogram mass block is hanging vertically from a spring, the spring stretches 4.5 centimeters from its normal length. The same spring and block system are then placed on an incline of 15 degrees where the block has a coefficient of static friction of 0.358 and a coefficient of kinetic friction of 0.300. What is the maximum length that the spring can be stretched so that the block will not slide when released? And then what will the acceleration of the block be if it is made to slide from this position? So I've read the problem. That's always the first step, right? I think it went without saying. I certainly did put it in my list of steps there. You do need to know what the problem is. So now I need to draw a physical diagram. And I already drew the physical diagram putting the knowns on there. At this point, I have to deviate a little bit from my steps because those generic steps aren't going to apply for every problem exactly straight. You have to be paying attention. In this problem, it starts off by giving me information about a spring. So I have to think about, what do I know about a spring? I definitely have a spring involved in this problem. And what is the fundamental equation that you have learned about springs? It's called Hooke's law, in case people need a name for it. We learned a fundamental equation for the force of a spring. Good thing we're doing practice problems then. Hooke's law says that the force, and I'm just doing the magnitude so I'm not putting the minus sign. The force supplied by a spring is equal to a constant K times the amount the spring is stretched or compressed. Usually we throw a minus sign in there because it's a restoring force. It's a force that is going to go the opposite direction you deformed it. So if you compress the spring, it's going to push out. If you stretch it, it's going to pull back in. That's why we used to put a minus sign. But here I just care about the magnitude, how big the force is. So in the first 2 parts of my diagram, notice I have 3 parts of my diagram. I have the spring just lying there with nothing on it. And then I have the spring with 100 kilograms on it. I'm going to look at the second case with 100 kilograms, and I'm going to draw the forces acting on it. So what forces are acting on the spring in the second diagram? Gravity. What direction is... These questions may seem very ridiculously simple, but they can be mistaken. That's why I asked them. What direction is gravity pointing? Down. And what's the magnitude of that force of gravity? Okay, the acceleration of gravity is 9.80 meters per second squared. The force of gravity is mg, where g is that 9.80 meters per second squared. So I have the force of gravity down. What other force do I have acting on that box? I have what? It's actually not tension in this case. We call it the force of the spring, because it's not just hanging from a string, it's a spring. So I'm going to have that force of the spring up. So there I've drawn the forces on my diagram. Now I'm going to draw a free body diagram for that box. Very unsophisticated. And for this, I'm going to put here positive y or positive x direction. No, let's call it y. Positive y direction. Now that I have that done, I can use Newton's second law. Why do I draw or make a free body diagram? What's the whole point of the free body diagram? What? To apply Newton's second law. That's the whole point. So if I made a free body diagram, that's because I plan on applying Newton's second law. If I'm not going to apply Newton's second law, I'm probably not going to make a free body diagram. Remember, the free body diagram is showing all the forces acting on my object of interest. I probably should have put something in here that said to identify the object of interest right here. I forgot to write that in. Because that's kind of important because you make the free body diagram for an object. So now I'm going to use these boxes for the first part, and then I'm going to split them and do them again for the second part. So acceleration in the x direction. How much acceleration do I have if the block is just sitting stationary? 0. So that means my acceleration in the x direction or y direction, I chose y here, is 0. And then how many forces do I have? 0. Not 0. In my free body diagram, I have 2. So I'm going to have those. Force spring in the y direction, force of gravity in the y direction, equals. Now I didn't write x direction because I didn't even define an x direction for this portion because it's one-dimensional motion. So now I'm going to apply Newton's second law after I fill in what these are. Well, I've been writing them all along. K delta x minus mg. Why did I put a minus sign for the force of gravity in the y direction? Because the arrow was down. Because the arrow was down, I have a minus sign. Because up was the direction of plus y. So now I'm going to apply Newton's second law. So I take the acceleration in the y direction, substitute it. I take the forces and I substitute those. So I just need to add what I have in those columns. So I have k delta x minus mg equals 0. What does this get me? Well, the problem gave me m. M was 100 kilograms. It gave me delta x. Delta x was 4.50 centimeters, as I have drawn in my picture. But I did not know k, the spring constant, so the first thing I'm solving for here is the spring constant. So I solve this for k. Did I say 100 kilograms? 100 kilograms is that's a very stiff spring, just let me say. 100 kilograms. Remember, G is always a positive value. And so I put those in my calculator. 100 times 9.8 divided by 0.045. And what do I get for my spring constant? Actually 3, because I had 100.0 for the mass, so I was 3. So I have 3 significant digits, so it's good to the first 7. Well, round that to 8. But we keep all of our digits until we're done with the problem. Because if we throw them away early, we're throwing away information. Now I'm going to take this work and shrink it a little bit so I have more room for the next portion.
The units on K is in the tens.
Actually, they're not. That's a mistake.
There's no, yeah.
Thank you. I do appreciate being corrected. I don't like being wrong, but I hate worse nobody correcting me. Well, I hate worse, no. I hate them both. Okay. Question? Yeah.
What's the a variable that doesn't get units on it?
The coefficients of friction don't have units. Now, a question for you, why did I do what I just did? Why did I go ahead and solve and find K there? How did I know to do that? I didn't ask the question because you know what I've been doing? Physics problems since before you were born. But why did I do that? Why did I solve the first part? The question didn't ask me what the spring constant was. Why did I solve for that?
Did we see the question?
Yes. Right, it simply asked me what's the maximum length the spring can be stretched for the block to not slide, and then what the acceleration will be if we make it slide from that point. Didn't ask for the spring constant. Why did I do that?
Because you need it in your next step.
That's right, I need it in my next step. So I read the whole problem, and my brain has already figured out the pattern I need to follow. I know that you don't have this experience. You're not going to instantly see, I'm going to need the spring constant. So a lot of people would have started with the second part because that's what it asked about. And then you get to the point where you're like, but I don't know this, I have to find it. And that's perfectly fine to start with the second part until you realize, oh, I need to find this. How could I find the spring constant? And then revert back and find where you can find it. Okay, so now that we found the spring constant, we have a number for it. Now I do the second part. What's the maximum length that the spring can be stretched so the block will not slide when released? So I look at this picture that's now on the incline. And I'm going to repeat now drawing my forces. So what forces and what directions do I have acting in the lower picture? Name a force and its direction. Gravity going down. Force gravity equals mg. Okay, that's one. Next one. Okay, normal force going? Okay. He said perpendicular to the surface. On a picture, perpendicular is fine. In real life, normal's the word because we live in a three-dimensional world. But in a two-dimensional picture, that is the direction, perpendicular. So we have force normal like that. There is no equation for force normal. Force normal is whatever's necessary to keep it from falling through the surface. And it'll be as big as necessary until you break the surface. Okay, so that's another force. Third force. Okay, force of friction, what direction? Okay, force of friction, if it's stationary, it's going to be the necessary to keep it from sliding. If it's moving, it's going to be opposite direction, it's sliding. So right now, if we stretch the spring and the spring made it move, the spring would make it go up. And so the force of friction must be down to keep it from going up. And I'm just putting force of friction right now. We have an equation for it, but I'm just putting force of friction because I want to talk about it more carefully in a minute. What's the last force?
Can you explain
Go ahead.
just one more time the force of friction, why it's going down instead of going up?
Because the problem asks us how far can we stretch the spring before it will slide, right? So if you have the spring unstretched, gravity would be pulling down, the spring's not pulling, it could slide down, but that wouldn't be the maximum we could stretch it. So now we stretch it. If we stretched it a little, we would have gravity pulling down and the spring pulling up, and it would, and friction, whatever direction is necessary to keep it from sliding. You keep pulling down, the more you pull it, the stronger the spring is pulling up. And so you pull it enough, and you definitely need to force down the slope to keep it from sliding. And so the wording of the question is what told me that that's the condition I was looking to. Okay, what is the last force? The force of the spring, and what direction is that going to be? Up. Okay, so I need to make a free body diagram. So I'm going to take those forces and make them act on a single point. So here's my single point, and my forces are I need to decide on a set of coordinate directions. Right, I think that's step 4, right? Or 3, it's one of the steps. 3, my coordinate directions. What directions should I use for my coordinates here? There's some guidelines on the sheet. What's the first guideline?
Number 3, identify the nuclear directions.
And then you have A. Okay, if there's acceleration, then I want my coordinate directions to have one direction parallel to acceleration. Now this problem had 2 parts. One said for it to not slide. The second part said, what's the acceleration? So I'm going to look at that second part and say, that's going to tell me there is an acceleration. I need to choose one of my coordinate directions to be parallel to that acceleration. What direction is this thing going to accelerate? Up the slope. And so I'm going to make my coordinate directions. This little box here was supposed to be for my coordinates. So one direction is up the slope. What does the other one have to be? Perpendicular to it. So it has to be like that. And just for 100% clarity, this is tipped 15 degrees from the horizontal. This here was 15 degrees. All right, now I have to break my vectors into components. So I am going to now write down the names of the forces here. So I have force of gravity, force normal, force of the spring, and force of friction. These I put an X after each one to say in the X direction, although I already have it in my heading. Yes?
Will you be providing us with the equations like the last test, like before the test actually happened?
Yes, it should be on Moodle already. There should be equation sheet for exam 2 there already.
Oh, sorry, I couldn't read that. Now I can read it.
All right, so now I need to break each one of these forces into the components. So, excuse me. Let's do the easiest one first. Which one is easy? That's the only one that's not easy. So, why are they all easy except gravity? They're all parallel to either X or Y except gravity. Gravity is the only one that I have to actually break into components. So let's do the quick and easies. What is the force normal in the X direction? 0, because the normal is parallel to the Y, perpendicular to the X. So force normal in the X direction is 0. In the Y direction, it's the full magnitude of force normal. I don't know what force normal is, so I just put in force normal as my variable. So the force normal in the Y direction is force normal in the X direction is 0. Going to the next easy one, the force of the spring. How much is that in the X direction? K delta X. And how much is it in the y direction? All right. Force of friction. Now with the force of friction, remember I said I was leaving it just as SFF because I want to talk about it more. Two kinds of friction. And in this problem, we're going to work it with both kinds of friction. The first one is for it to not slide. Which kind of friction is it if it's going to not slide? Static. And the static friction doesn't have an equality. The static friction is less than or equal to. But the problem said at the limit. It said what's the maximum distance you can stretch it before it slides. So that means we want to have the maximum static friction. So even though the force of static friction is less than or equal to mu times force normal, we're looking at the limit where it's equal to. And so I'm going to put equal mu sub s times force normal. How much is the force of the spring, or excuse me, of friction in the y direction? Force of friction, how much of that is in the y direction? None of it. Now we have the easy one that Ryan chose. The force of gravity, and I'm going to do this very explicitly just to make sure people don't get confused. So here's the force of gravity with magnitude mg. Then I'm going to take, at one end of it, I'll draw a dashed line parallel to my y-axis. I missed. And from the other end, I'll draw a dashed line parallel to the x-axis. So those are perpendicular to each other. And then I know that I'm starting at the tail of my vector and adding the components to get to the tip of my vector. And they have to fall in these dashed lines because the components are in the x or y direction. So then I just start at the tail, and there's one component. There's the other. Now keep in mind this was the positive x direction, and this was the positive y direction. So if we look at these components, better put the angle in. There's the angle. Go ahead.
How did you know to start from there?
To start from at the tail?
Yeah.
Okay, you could draw your dashed lines from either side. I could have just as easily drawn like this and like this. I would have had an equivalent triangle. So I just had to start at one end and put parallel to one of my coordinate directions, start at the other end and put parallel to the other coordinate direction in the direction so they will meet. So I did have to choose the side where they will meet. Or if I really wasn't with it, I could have drawn both directions and then been, oh, look, they actually meet on this side. So there's not special thought or knowledge necessary. Just draw a dashed line from one end parallel to one of your coordinate directions, from the other end parallel to the other one. And then where they meet, you can then draw in your x and y components by just starting at the tail, drawing an arrow along dashed line until they meet, putting your arrowhead, then drawing the next one. Okay, which of these two sides of the triangle is my x component? I didn't hear what you said, Ryan.
The bottom.
Bottom one.
Yeah.
Okay, I did hear. You said bottom south?
Bottom side.
Side, okay. I thought I heard bottom south both times. I was like, so there's my force gravity in the x direction. Makes this one force gravity in the y direction. Now in terms of trigonometry, one of those is the adjacent side, one of them is the opposite side. So which side is force gravity in the x direction? Opposite. So sine of an angle is equal to the opposite over the hypotenuse. So if I want to solve for the opposite, I just get force of gravity in the x direction is equal to mg sine of 15.0 degrees. So I'll put that in here. Who wants to correct me? Okay, what did I do that's not perfectly right? Negative. I have to put negative because my positive x direction was up and to the right. This is down and to the left. You have to pay attention to the directions to get your signs right. Okay, so that's my x direction for the y direction. Which side of the triangle is the y component? Adjacent. And so that means adjacent is the one that's related with cosine. Now, is this going to be positive or negative? Negative. Negative because positive is shown as up and to the left, and this was going down and to the right. Now I have all of my forces identified. And notice I do know what M is. I don't like to put in numbers until I have to. So I haven't put in any numbers yet, but I know what M is. I know what G is. If we go to the other column, I know what K is. I know what, no, I don't know what delta X is. That's what I'm looking for. I know what mu sub S is. So now if we look at our variables, I'm going to use green to identify the unknowns. We don't know delta X. We don't know force normal. So I have two unknowns in the y direction, or in the x direction, one unknown in the y direction. A total of two unknowns, because Fn is on both sides. What's the straightforward way of solving this?
To solve for y.
Solve for y first, because I have only one unknown. Hence, I know I'm going to get my answer. So I'll solve the y side. So sum of the forces in the y direction is mass times acceleration. Write it again. And now I just, for replacing the sum of the forces, I add the things. Notice we had two problems. So I'm not looking at the black numbers anymore. Don't get confused on that. We're doing separate problem now. So I'm just going to add the things that are blue in the y column. So that's going to be, and I always put a positive first so I don't have a leading negative sign. Equals mass times acceleration in the y direction. We know doggone well this thing isn't going to hop off of the slope. So it's going to have a constant velocity of 0 in the y direction. Hence, the acceleration in the y direction is 0 because of constant velocity. Hence, my 0 up here still holds, equals 0. And I solve right away. Force normal is equal to mg cosine of 15.0 degrees. An important thing to note at this point is a lot of people simply default and say force normal is mg. Force normal is not mg. Sometimes it is. A lot of times it is. Right now on me, force normal is mg. But it's not always mg. So I needed to calculate it. Now that I have the force normal, now I'll come to my x direction. I know what force normal is. The only thing I don't know is for finding the maximum acceleration is 0. And I do sum of the forces in the x direction is equal to mass times acceleration in the x direction. Bring things down. And I have that equation. Notice I had 3 non-zero things I had to write here. And now I'm solving for delta x. So for force normal, I substitute what I just found for force normal, which is right down there. Mu s times force normal. That should have had a minus sign there. Or the easiest way to write that is delta x equals mg over k times sine of 15 degrees minus mu s cosine of 15 degrees. And then we have to put in our numbers. And then we have to calculate that thing.
Where did the 0.35 come from?
That's the mu s. That's why I actually scrolled up. I scrolled up so I could read it. And somehow I got a negative answer, which makes no sense. Here's my mistake. Force of friction was going in the negative x direction. Should be a minus sign there, which means there is a minus here, which means there's a plus there as I had originally written by accident, but now is correct. It's like, that doesn't work, and it has to work. Let that be a lesson. We all make mistakes. We try not to, of course. Anybody have an answer? Good, because that's what I got too. So there we have the distance that this spring can be stretched with this 100 kilogram mass on it and not slide. Any more and it's going to slide. Question?
How was it? Was it in your Freebody diagram when you saw that the force of friction was supposed to be negative?
Yes. It was when I looked here and I saw my positive direction was up and to the right and the force friction was down to the left that I realized, whoops, I put the wrong sign. And as you can see, it's very important to get those signs correct. Now that is finding how far it can be stretched and it won't slide. But now I'm saying, what if I make it slide at that position? What will its acceleration be? How is that going to modify my problem? Good, what do you say, sir? Okay, it's going to change from static friction to kinetic friction, and the acceleration is now going to be unknown. So I'm going to change colors and put a question mark here because I don't know it for the second part. But now this is going to become minus mu kinetic force normal. So everything else stays the same except for now it's not equal to 0. So I'll do the sum of the y direction didn't change a bit. Only the x direction changed. So I'm just going to redo sum of the forces in the x direction is equal to max, and now I'm solving for ax, excuse me. And so once again, writing the sum of the forces, which I had done right there, somehow my mu got erased there. So I am close to done. I just have to divide everything by m. I have to hit the right spot. And I have and once again, I just got to put that in the calculator. That's a whole bunch of numbers. I'm going to give myself some more space. Maybe. That didn't seem to do what I wanted. There we go. And I remember I made this one easy. Mu for kinetic friction was 0.300. Do you have an answer already? I am just going to believe my students rather than taking the time to plug it all in because I've been writing all this stuff. So, zoom out a bit. There we have all of the work for the entire problem. Any questions that you have about any step in the problem? Now's the time to ask. Yes.
So, like the very last problem, your very last equation, I saw you put plus micro-K for the kinetic friction.
Right, because I factored out the minus sign. There was a minus sign here and a minus sign here. And so when I factored out the G, I also factored out the minus sign. So I had the minus right here, G. It's important to get those things straight, right? Because it makes a big difference. Michael.
Can you go back a few steps to how, after you want to solve for the numerical on the x-axis again?
After I went to solve for what?
When we're solving on the x-axis, that we got which one was solved.
I'm not sure what you're talking about.
Hold on, let me find it. Okay, so the variable for the x-axis.
Okay, so the delta x, to find how much we have stretched.
Yes.
Okay?
I just wanted to see the step-by-step process.
Okay, so I'd broken everything into components. So I had my forces here and the acceleration was 0. For that part, the acceleration was 0. And so I have Newton's second law, sum of the forces. And so the sum of the forces, I added up everything inside that black box. The reason I didn't have the other parts because that was the last part of the question, not this part. So I added up all those things. That's why I have it nicely broken up into a column, so I can just add up everything in that column, and that's the sum of the forces. And then it's equal to m times ax, so there was the ax. So everything that appears in Newton's second law, except for mass, was in that column. Any other questions?
I understood that, that solving process that you just did right now. I think the thing that would throw me off would be in the beginning, and I still don't understand how you knew that way over there where you were doing the vectors in the drawing. That's the part that I feel like.
This?
How did you know it would start there? Like, I feel like I would have made the mistake of drawing it to the right and then drawing it up.
Well, you know the mg is straight down, right?
Yeah.
And you know that you have your coordinate system. Well, I didn't need to do them dashes, but had the coordinate system like this so that it had one parallel to the acceleration.
Yeah.
And so then I just took an end, didn't matter which end, and drew a dashed line parallel to one of those. Didn't matter which one. So I can start at this end and I can either go like this, that's parallel to y, or like this, that's parallel to x. And then I go to the other end of my vector and I do the same thing. Well, I do the opposite. So here's parallel to x. There's parallel to y. Now I could either choose to make my triangle starting here, going like that, and going like that, or I could choose to make it starting here, going like that, going like that. Either one is perfectly correct. Either one will give you the right answer. You do have to pay attention to your angle. We knew that this angle here was 15 degrees, which means this angle here is 15 degrees. And so you have to make sure you know you have the right angle in the right place.
Okay. I mean, I just don't know what you mean by it doesn't matter what end you start off in.
In terms of drawing those dashed lines for the x and y direction, it doesn't matter where you start as long as you start at one end of the vector. And then the components have to add to give you the complete vector. So you need force in the x direction plus force in the y direction is equal to the total force. And so since vectors add tip to tail, it has to start at the tail and have one component and then the next component immediately after it.
Oh, okay. I'm starting to make a little more sense here.
Okay? Any other questions here? All right, we have used up almost an hour already. Problems don't necessarily go quickly, especially when you're explaining everything and when you make a mistake with your signs and so on. And who here doesn't make mistake with signs? Hope no one raises their hand on that. You're stretching, right, Madison? Yeah, okay. Okay, going on to problem number 2. A roller coaster, yay, is designed to have a loop with a radius of 18.3 meters. If the roller coaster car is on the inside of the loop, so occupants are upside down at the top of the loop, what must the speed of the roller coaster be at the top of the loop for the occupants to feel the same normal force from the seat as they did when they sat in the car when it was stationary on level tracks? So first step is draw your diagram, your physical diagram. Second one that I didn't write in here, identify your object. What is our object here? You could use the cart, but it would be better to use the person because it specifies for the person to feel the same normal force. So since the problem specifies the person, you should use the person. You'd get the same answer if you use the cart. Question?
So it's because it said it in the problem. Sorry,
Yeah, the problem says occupant feel the same normal force.
Okay.
And so that's my hot tip, that I'm going to use the occupant as my object. Now notice it doesn't tell me the mass of the person, but it tells me that they're going to feel the same normal force that they would feel if they were on the ground. Quick and easy. I'm not going to draw a free body diagram or do any work on it. What is the equation for the normal force you feel when you're on the ground? What?
It's equal to the force of gravity.
It's equal to the force of gravity. Now, I said quick and easy, I'm not going to do the problem. I will explain it. You know that if you're just sitting stationary, your acceleration in the vertical direction is 0. And all the forces act on you in the vertical direction is force of gravity down and force normal up. So if you apply Newton's second law on yourself, it's a trivial problem. Sum of the forces, which is going to be force normal minus force gravity, is equal to mass times acceleration, which is 0. So force normal minus force gravity equals 0 means force normal equals force gravity. That's why we usually fall into the trap of saying force normal is force gravity. But that wasn't the case in the previous problem. So in this case, we know that we have a force acting on the person that's force normal equals force gravity. I drew force normal down. Why in the world did I draw force normal down? You're upside down, and the force normal is keeping you from pushing into the seat, but the seat's above you. So it's pushing you down to keep you from going into the seat. I meant to ask you what direction is the force normal here because it's really an important concept. I accidentally wrote it first. You can't unring the bell, so to speak. So, sorry, you missed that little chance to think about it before I gave you the answer. So I have the force normal down on the person. What other forces do I have acting on the person?
Gravity.
Force gravity, which acts. That time I remembered to ask. There are no more forces. I'm not going to sit here and ask you to try to identify another force and force people to come up with wrong answers and then say no. It just seems a little dishonest to try to get them to come up with something when the answer is there is none. So that's all my forces. So I have completed my step 2. I've drawn, or step 1, drawn the physical. So now I do my step 2 free body diagram. So here's my object. I need to identify my directions. What's the first rule for identifying my directions? Well, the perpendicular. Okay, the perpendicular. What's the first rule of the AB? Well, for identifying that, what's our first rule?
So acceleration parallel.
Yeah, acceleration parallel to an axis. So do I have acceleration here? Yes is the correct answer. In what direction? Toward the center. Perfect answer. Down would have been correct, but it would have been, did they say down because if I drop a ball it's down, or did they say down because they understand that it's toward the center and at the top toward the center means down? He answered toward the center. There's no question. He knew what he was answering. Good job. So I need to define my directions. This is one-dimensional. So I'm just going to define that direction. We usually actually call this the C direction, toward the center. And so I'm going to come down here, and instead of X direction and Y direction, I'm just going to put C direction for one of them. Acceleration toward the center. So now we said there's an acceleration, it's toward the center. What name do we give the acceleration toward the center? Centripetal. And we have an equation for the centripetal acceleration. So what's the equation for the centripetal acceleration? I swear I heard somebody start at least. Okay, it's V squared over R, or as you learned, omega squared times R. We want to know the speed, so I want the first one of those. If I'd wanted the angular velocity, I would have gone with the second. So because I want the speed, I'm just putting v squared over r. Now the forces toward the center, what are they? Well, that was real easy. I've got all my forces, got them written in. They're a positive. Why are they both down and yet positive? Because I identified the center direction as downward, so they're parallel to the center direction. That makes them positive. What's the final step? By the way, folks, guess what we're doing for lab tonight? Maybe not going outside looking at it. 3 students are all, oh no. What's the last step, everyone? It does say it here. Okay, that is the last step in the list, but in this case, that step is trivial. It's applying Newton's second law, which isn't hard either. I can't fault you when you write down what it says as the last step. Okay, sum of the forces toward the center is the mass times acceleration toward the center. The mass of what? The person, which is the same as the masses I have in force normal and force gravity. So I put this in. Once again, I will take these things and substitute those for sum of the forces. So I have mg plus mg equals m times, and then I take this and substitute that for acceleration. So everything that I put in Newton's second law was there in my columns, except for m. And now life gets so hard. There's a mass everywhere, so what should I do with the mass? Divide it out. Factored out is actually good terminology. Dividing out is only valid if the mass isn't 0, but fortunately the mass isn't 0, so it's legal. Factoring out, you still would have been, within legal grounds. Well, now I have v squared over r is equal to 2g. So v squared is equal to 2rg. So v is equal to plus or minus square root of 2rg. I put plus or minus because I want to be technically correct. But I'm only looking for the speed. That's a magnitude. It's going to be a positive number. So the negative makes no sense when you pay attention to what we're looking for. And so we just have square root of 2rg. 2 times 18. I should just write this down. And we get our speed. Now that one took far less time. That one only took 10 minutes, start to finish. And of course, if you don't have to explain everything, you can go quicker. I want you to be learning from this. That's why I'm explaining and asking questions. So now that we've solved this, any questions about this solution?
I just have a quick question about it. So you said that, and would the problem itself specify whether it wants the velocity of the person or whatever? Would it specify if it said angular velocity? Would it say it is?
Yeah, if it wanted angular velocity, it said what is the angular velocity, said what is the velocity. Or I'm not sure what I wrote, if I wrote speed or velocity. Michael.
Can I just see the answer you got?
Okay, any other questions about this problem? DJ.
So, since the normal force is always going towards the center, it wouldn't matter where the car is in this instance. Like both of those would always be AC.
Okay, let's take what DJ is asking and use it to make sure we understand the situation carefully. So what if the person had been on the side here and said we want them to have the normal force equal to what it normally is at that point? If it's at that point and I draw the Freebody diagram, what am I going to have?
You're going to have FG going down.
I'm going to have force of gravity is going down, and
Normal force is going to be going toward off the track.
so then I would have had force normal in one direction, force of gravity in the other. And that's a two-dimensional problem, but my acceleration is toward the center still. And so I do my forces, and I would have had the force of gravity shifted over to the y direction. And then if I look in just the direction toward the center, it would have only my unknown I'm looking for and knowns. And I would still been able to solve, and it would have been, square root of 2 times this, or square root of 1/2 times this answer. It would have been 70% of this, 71%. Say 71%? Yeah. I think that's right. Yeah, it'd be slower. You'd not have the same force downtime. So yeah, the key there was the forces are not acting in the same direction there, so you have a different number. Okay, any other questions about that? Okay, let's take just a, you got another question?
This is just adding up to the y-axis.
Run that by me again?
This will be, this is just for the the x components, right?
We just did the center component because it was one-dimensional at the top. And like I said with DJ's question, if it had been on the side, then it would have been a two-dimensional problem. I still would have only needed one of those dimensions, but I would have had 2 dimensions if it hadn't been at the top. Okay, let's take 8 minutes. So at 3:10, we'll come back and do the first one that you have to actually write out.
Before you guys all run to break, does everyone have 2 copies, 2 blank copies of paper
Of the
to be able
paper.
to do your problems on? If not, I'll go make copies. Okay. I'll have each of you grab 2 blank copies.
Thank you.
Yeah, you're welcome.
Oh, I see how it is. You're being challenged by the young Padawan.
3.
We actually already talked about that. That was the light gathering power is the area of the aperture, so pi diameter squared root of 4.
Yeah. So, with the resolution?
Well, okay, so this one here, that's just, it's inversely proportional to the diameter. So that means the resolution is proportional to 1 over diameter. And so all you're looking for the ratio of resolutions is the ratio of 1 over diameter this divided by 1 over diameter that.
So we have to figure out what the diameters of those 2 are, given if there's 60 meters or
Yeah,
whatever.
yes, you need to look at look at, that's something that you need to just look at those telescopes to find out what diameters are.
While they're on break, can I move your screen to the last problem that they're going to have
Sure.
to work out by
Yeah.
themselves?
Yeah.
So that I can start on that. That way at least I've got one in there. Which one are they doing by themselves? I
Yeah,
can't remember.
yeah,
Is
it's,
it this one or is
that
there
one.
one after?
Yeah, that's the one.
Don't mind me asking,
I don't know.
what were the announcements during?
Oh, it was about next week going to Defy Gravity. You need to fill out the waiver that's on Moodle before we go. And if you need a ride, I'm expecting students to meet me there at 2:15. If you don't have a ride and you want to contact me, I'll try to make sure you have a ride.
Okay.
If you have socks from Defy Gravity or Jump Zone, bring them because that will save us like $1.75.
If we don't, I need to bring $1.75.
No. The department's covering it.
Oh, okay.
Just if you have some, it'll save the department some money.
Yeah. Cool.
So do you have family in the area that are constituted by your grandmother?
Yes.
Surprise, thanks. Yeah, surprise. Is the next problem the one that we're doing together?
Yes, I'm going to do the car one next, and that's the one we're doing together.
Is the one that we're supposed to do by ourselves, is that one similar to this one that we're doing right here?
It's the one that she's looking at right now.
The child signing up?
Yeah. So where you said you lived there? Did you live like in Hartsel or like out in the villages or? I mean, not like Hartsel's not in the movies.
That one,
Like,
which you guys watched.
yes, maybe.
I just have it, but I'm so you guys like
Is that
But I'll find out that one's like
Towards Kansas City.
Awesome.
So we
I actually have one question from our homework, but it's very simple. Okay.
I'm fine. Yeah.
And this one. This one.
When you were scrolling, I suddenly became concerned that there was another problem I'd forgotten.
Well, I was like, I can't tell if there's another like problem after these or.
Look, Wes has room for his legs. It's a miracle. You don't know which way to take it.
So we're doing this one.
This one is the first one you have to write down, yeah.
Oh, okay. Wow, that's good. It's what I hate. That's what I don't like about this. There's like some terminology I don't know. I mean, I would, but you can do the exam, so.
Okay, starting up again. This problem here is the one that you need to fill out on one of these forms, following along so you show that you can follow the sequence. And then you're going to do another one that I'm not leading you on. Each one of you needs to do the problem, not in pairs, for the last one. So our problem is a car in a banked curve is moving away and turning to the left. If the curve has a bank angle of 5 degrees and a radius of 55 meters, and the tires have a coefficient of static friction of 0.75, what is the highest speed at which the car can complete the turn? Now let me point out right off the bat, the problem asks, what is the highest speed? There's significance to that. What does it tell you when it asks, what is the highest speed? There's a very important ramification for it. That's why I'm asking.
Well, if it can complete the turn, then the net force is 0.
Well, the net force isn't 0 because it's accelerating, but the maximum for it to complete the turn is when you have enough friction to be able to complete the turn. And so you're going for the maximum possible friction before the tires start to slide. And so that tells us that our force of static friction is not going to be less than or equal to mu s force normal. It's going to be equal to mu s force normal because we're at the limit. So that maximum speed is important to understand. It puts you at the limit. Question,
So
Leslie.
anytime we're dealing with problems like this, when it talks about like maximum speed, we're always talking about maximum friction? Is that?
Usually, yes. I can't say every time. But it tells you, it has things like maximum this for a reason. It's not just throwaway words. Right? Because otherwise, it's also safe to go slower than this speed, right? And so if we just said, what speed is safe? You could say, well, I suppose 10 miles an hour is probably safe. It doesn't help you. And so that's why they're going to the maximum. Okay, so having the problem, the first step, draw the physical diagram. I drew 2 physical diagrams. One that's a top view, that is the bird's eye view looking down, and one that is the side view. The side view to me is the one that's useful for solving the problem. The top view, though, is important for me to get in my mind what's actually happening. It's going around a circle. If it's going a circle, that tells me there's an acceleration. So let's go ahead and show forces. Which one do you think is going to be more useful for showing forces? Well, let's try it. I heard somebody say the top one. What are the forces acting on the car? Force of gravity, which is acting down. So I can put like this, force of gravity. That's how we indicate into the picture, a circle with an X. It's supposed to be you're looking at the back side of an arrow, so you have fletchings that are simple crossed fletchings. So that's how you indicate the force of gravity going down. What other forces do we have? Normal. What direction is the force normal? I have no way of drawing that. Right? The force normal is going this direction. I can't draw that direction. I mean, some people who are talented probably can, with shading and whatnot. I can't. So I was okay with force of gravity, even though it's not nice. That one I just can't do. But if we come to the lower view, the side view or rear view, whatever you want to call it, then it becomes simpler because the force of gravity is mg down, and then we have the force normal. Other forces. Friction. And what direction is friction going to be if you're going as fast as you can without sliding off the curve? Down the slope. And notice I put equals mu s force normal because we had that, what's the maximum speed? If it didn't say what's the maximum speed, I would have had to have less than or equal to. Okay, that's it for the forces. Huzzah! What direction is the acceleration? Toward the center. It's going at constant speed. So the acceleration is like that. So now we need a free body diagram. So free body diagram, here's my car. And we have to choose a set of coordinates. What direction should we choose for our coordinates here?
Normal with friction.
Do what?
Normal with friction for the perpendicular.
I would, now you can do it that way, but I recommend not. I recommend choosing so one direction is parallel to the acceleration. And so I'm going to have one direction like this, parallel to the acceleration, and I'm going to call that the center direction again. And then what direction should I have for the other one? Needs to be perpendicular, so what direction is perpendicular to the center direction? Okay, vertical. Okay, so you said down, so I'm going to make it down. So that's not the standard directions for positive. We need to keep those directions in mind. Because they're not standard, I could make a mistake more likely than normal as well. And you already saw me make one mistake with direction. You have to pay attention. So now that we've got our free body diagram drawn, we've identified our directions. Let me change that to C again, toward the center. What's my acceleration toward the center? Right, V squared over R. What's my acceleration in the Y direction? 0, right. We chose our direction so we'd have all of the acceleration in one direction and none in the other. To make our lives as simple as possible. Now I have my forces. There were 3 forces, so force of gravity in the center direction, force static friction in the center direction, force normal in the center direction, force of gravity in the y direction, force of static friction in the y direction, force normal in the y direction. Doing well. One of these is easy. Which one's easy? Gravity.
Hey.
You know it has to come up eventually. Okay, so how much is gravity in the center direction? The force of gravity in the center direction. 0. How much is the force of gravity in the y direction? It's mg, that's right. That was Ryan again, by the way. It's mg. Why is it not negative mg? Because we define down as positive and it's down. It doesn't mess up our problem to do that. Oh, I put on normal instead. You're right. So sorry. All right, now we've got the other 2. Which one do you want to choose first? Okay, static friction. Now I'm going to once again do this in gory detail. Here's my mu s force normal for the hypotenuse. My directions are like this and this. So I go to one end and draw dashed lines parallel to, I'm doing each direction here. Makes life easier for Leslie to see everything. And then from the other end, I draw parallel to both axes.
Okay, now.
And then I need to start at one side, or at the tail, and just choose a direction. I don't want to choose that direction because that's going to interfere with where I wrote mu SFN. You have like that. So this is going to be force static friction toward the center, force static friction in the y direction. What is that angle? 5 degrees. So now we use our trig functions. Which trig function am I going to use to find the center component? Cosine, because that's the adjacent direction. Right, you always have to look at the triangle. And so we have and is it positive or negative? Positive because it's pointing the same direction as our center direction was. Okay, which trig function do I use to find the y component? Sine. And is it positive or negative? Positive because it's pointing the same direction.
It's all because of what we defined
Yes, it's all because we defined down as positive. Normally, I would have defined up as positive and we would have had negatives. It wouldn't change my outcome. It just changes the signs as I go through it. Finally, I have the force normal. So the force normal vector is going like this. And this time I'm only going to choose one set of dashed lines. So for the center part, the center arrow, is that going to be sine or cosine? Sine, because it's the opposite. And is it positive or negative for the center one? Positive, because it's pointing the same direction as my center arrow was. Okay. For the y component, sine or cosine? Cosine. And is it positive or negative? It's negative because somebody said that we want y to be down, and that's going up. So we have negative force normal, cosine of 5 degrees. Okay, we have now broken all of our forces into the components. We've identified our accelerations. Let's look for what are unknowns. What are the unknowns in this problem? It's true that we don't know the acceleration, but we're not asked for it. And we have a substitution for it. So force normal, in other words, let me say the thing's on the right side of the equal signs, because the acceleration is on the left side of the equal sign there. Right, the right side's of the equal signs in the table. So force normal's everywhere. It's still only one unknown, even though it's 2 on each side. What's the other unknown here? Velocity. So once again, we have one direction, has only one unknown in it. The other direction has 2 unknowns. The logical mind says, man, it's coming down outside. The logical mind says, let's do the side that has only one unknown, solve that, and then do the other side. So sum of the forces in the y direction is equal to mass times acceleration in the y direction. Just reading from our columns, I'm now going to turn it over to I'm looking for somebody who said nothing. To Hannah. What do I get for some of the forces in the y direction? Okay, somebody want to help? I have the stuff there in the box. That's why we wrote them there. So the sum of the forces in the y direction is mg plus mu s. And what's the acceleration in the y direction? 0. So there I was able to use the things I have in my columns to very quickly fill out Newton's second law. Everything was guiding us into doing Newton's second law. I'm looking for force normal, so I'm going to subtract mg from both sides. And factor out force normal. So there's an equation. Now it looks like I have trouble, but I don't. The reason I don't have trouble here is because, number one, notice it didn't give you the mass of a car. Not trouble. I'm just going to leave m as an unknown. Number two, cosine of 5 degrees is much bigger than mu s sine of 5 degrees, so I have negative over negative. It's a positive value for force normal. Force normal can't be negative. A negative force normal would imply that you have to apply a force to keep it from leaving, and that's not a normal force. That is something that's tying you down or glued on. Force normal is to keep it from going into the surface. So here I solve for force normal with an unknown m. At this point, you could be edgy, but I, as an experienced physics problem solver, have gotten past that edginess. I have faith that the person who wrote the problem gave me everything I needed. My faith is not always justified, by the way. Now I turn to the x, or not the x direction, the center direction. And once again, okay, so let's go to Clayton. What do I have for some of the forces in the center direction? Okay. We just add those forces up. That's why we've done it. So I'm going to be really redundant. I'm going to put 0 first. And then we have mass times acceleration in the center direction. We have written up above, acceleration in the center direction is v squared over r. Now notice both of these had force normal. Now I will substitute in my force normal equation. And then I'm just going to write in here Almost done. What can I cancel?
Wait, what did you?
The stuff in green was force normal.
Oh, so you just deferred. Oh, okay. Just kidding.
So I substituted for force normal all the green stuff.
Technically, if we wanted to, could we have written them two separately, just multiplying to each other, or would that be wrong?
Yes, you could.
Okay. I just want to make sure you understand.
This was just taking less space in the page. What can I cancel here easily? Mass. Yay, because we didn't have mass. Now we know everything else and we can solve this. So v squared is equal to, I have to multiply across by r, so rg Now, please note, I'm reversing the order of things on bottom. Because I'm changing the signs of everything on bottom. So what I've done is I've taken the negative sign here and distributed it to the bottom to change those signs.
So that happens after you manipulated everything and.
Well, I could have done it at any time, but this is where I chose to do it. Because now I don't have, instead of having two negative signs, I have only one negative sign. It makes me happier. And now we just put in our numbers. So R is 55 meters. And you pop that in your calculator and a number should come out. I am not going to write down the number. I want people to go ahead and calculate it for themselves. That's the first of the two problems that you need to have done and turn in. So, questions first. Zoom to where? To here?
Shouldn't everything be square rooted?
Yes. Thank you. I will correct that. Thank you very much, Emily. That would change the answer, dramatically. Your units would have been meters times meters, meters squared per second squared. Okay, now back to what you were saying, Michael. What is it you want to see? Can you, well, is this, okay. Okay, somebody else had their hand up. Clayton, do you have your hand up? No. Sarah.
Didn't the register say that velocity squared is equal to the square root of
Yeah, I have square root that too. Yeah, my equation was correct, but I have square root everything. Yeah. DJ.
What is R?
R is the radius of curvature for the term, which was given as 55 meters. That's
So, it's like I understood the process, but that bottom part when you switched everything,
bottom part when I switched everything.
yeah, the negative, well, more like just the negative, but, I mean, still not understanding why, is that like, is that after you moved everything around, that's what it would have looked like, or?
I was just rearranging to solve for my unknown. And I don't like having a leading minus sign, so that's why I changed it. It wasn't necessary. I still would have had the right answer.
Okay, so it would have been the same thing if I would have just left this negative sign?
Yes.
Oh. Okay.
DJ, do you have a question?
Yeah, the given for static coefficient friction
Was 0.75.
It's gonna take a lot of calculating.
answer for the second one. I haven't finished working through it yet. Okay, sounds good.
Are you good if I put more in the back? Because
Yes.
there's no-
Yeah, I expect you'll probably need to use the back side of your paper. You notice I went below the bottom of the paper.
Can I see the top part, like just the question?
Okay, now you don't have to stay when you're working out the last problem, but if you do, you have TA Ashley here to help you or me to help you if you have questions along the way.
Can you go back down if he's finished?
That's good.
If I don't have space, can I just write that in, or do I actually have to?
Yeah, you can.
What is it?
Let's go on this thing.
Sure, go ahead. I think it's I know, but why are you? Is it the same?
Can you bring the laptop with it?
Oh, that's right. I didn't give you a paper with the laptop on, did I?
Yeah, you guys might want this.
Can you zoom it out so they can see better?
Is that better?
it's supposed to be around, because we keep getting to do attend to the PHYS.
Yes. Yeah.
Hey, Ashley. Where's, can you put the date card? What's the graphic? Okay, so, this is one and your
Yeah, that's what you're asking.
So your friction is going on the second is increasing. Right, because otherwise the spring can accelerate and move up. And that makes sense because if we were to slide something, it would slow down. Right, so our force of friction is on. So with this, award, just is K. That's the way that it works. But our friction is so
So they're setting your train over 25, so it's not a big.
and then yes, your net pressure, but that yes. You have to understand that your static will be fully opposite of it because it wants it to stop. Right. Yeah, that makes sense.
So we're gonna have to select the. Our normal is going down.
Okay. So yeah. She is like.
So I've handed back the test forms. These are just what you turned in. There's no additional marks on this. The look on it was where you did everything else, including the test is available all the time.
Are you working on this?
Okay, so got your force normal, your force gravity, and then what all do you have going on over here?
Force of friction. Start friction. Or connect that coefficient.
Okay, so okay, so with this, what's your acceleration? And your force normal. So would your force normal be sitting on your axis, or is there going to be an angle?
There would be an equal.
Okay,
So be stretched on that.
so is what I'm saying is with this, you've got your axis. So this is in line with your force of friction here, and then your y-axis needs to be perpendicular.
Oh,
The
I see.
perpendicular would be your force normal.
I see.
So you don't need that angle aspect there. And then let me do a double check on your force friction if it's just this way or if your kinetic would also be the opposite. I want to say your kinetic should be the opposite, but I have not been able to fully do it from yet.
Okay.
Let me double check on that for you. So,
I was thinking about that.
okay, so you're going to accelerate this way, your force of friction,
In line.
right?
Yes. That is,
Perfect.
it has a length equal to hypotenuse. That's the
There, yep.
So
And
this,
then, so for your F and G, for solving that, what are you gonna have to do there?
well, that's, okay, that's the best I can do.
And then you'll have to figure out that angle. Right. And yes.
That's good.
My biggest struggle, not actually the calculation part.
I was gonna say,
Drawing
don't
picture.
make your picture too, like, don't think too much about it.
Yeah, because that's the thing, I struggle so bad, and if I don't draw the picture right, I'm gonna get it wrong, so.
Don't think too much about your picture, just draw a triangle.
Just draw a triangle. Oh, so like, but like, that's the thing, it's like,
See, you don't know what the angle is yet, so if you just draw your triangle, you know the wrong incline of some sort.
well, like, would it be this angle or this angle? That's the thing.
What exactly?
Would it be this angle here, or would it be this angle here?
So they're sliding down on the grass. So say this is your whole grass, and they're sliding down on a piece of cardboard. Draw your person on the cardboard.
If you draw a triangle, it's gonna be exploded.
Okay, we're trying to figure out that works. We're trying to figure out the angle of the hill.
X2.
Oh,
So
how do you know
that's-
it was up the hill?
You just
I always struggle with this part. This is like the worst part for
what
me.
minimum angle is preferred for a child to overcome. So you just kind of have to understand that your child, like when you draw any of these, you know, sort of problems and you're setting on an
This
incline,
angle wouldn't make sense either, because it's like,
no, you're trying to figure out what the incline is basically what it's saying.
okay, so what's the minimum angle required for you to, oh, minimum angle of the thing? Wait, but if you have no control over that, then you just don't do it because you can't program it, or?
So you're gonna make this theta so far because you don't know what theta is. That's the unknown minimum angle.
Okay.
What? So I have to discuss that with you guys. Okay, I'll send out an email. So we'll have Wednesdays 7:30 to 8:30, but Thursdays I need to see what works for you guys because 3:30 to 4:30 is not me. Wednesday, 7:30 to 8:30.
You can use.
Yes.
Oh, dang.
So.
With this, set up your unknown angle, and now, what's your object of interest?
I'm assuming that this part here. Wait, can I see it again? Do we care more about the person or the cardboard? I feel like it's the cardboard.
They're doing the same thing.
It's just this.
It's
Yeah, I'll be like, this thing.
Yep. Now, look at your forces acting on this individual.
Okay, so, it's acting on it. It's a force of gravity going down. Or would it be this way? The force of gravity would be pushing down this way, wouldn't it? Mm-hmm. Force, gravity, force normal this way. The force of friction would be going this way? Yes. Because it's talking about,
You could have done terms too wide, then we would have had D.
to overcome it. That's the thing. I know there's times where friction would be this way, which is when would that be the case?
So that's when, like with our spring, so our spring was the situation where if it were to accelerate,
That's right.
it would
There's not a lot of-
accelerate
not a lot of
in this
thought.
direction, like it would accelerate in
Just
this
a whole lot.
way. So then your friction has to be the opposite of that.
Yeah, I'm sorry about that. I'm getting a different one.
It's going down or it's going up? I don't understand.
It's, well, let's go with what direction would the first, the child move if there was no friction? So what direction is the force going to
Force normal here, force of friction's going this way. And then we have, yeah, so we have these here. Without y'all,
choose
these here.
X and Y rather than.
So yeah. And then draw this into your Freebody diagram.
So just
And then
like,
force of gravity
In
going
my-
down,
No, that's not.
force normal going
Right,
this
the wise
way.
one is to make one direction parallels the acceleration. And so when the child is accelerating, what direction they can accelerate.
okay. Now I was just thinking this because
Your picture's
So
opposite.
like this.
So I was like, no.
Yeah, the force of friction,
wait, so
and then
he's
force normal and force of gravity here.
the acceleration.
So what are you going to set up for your X and Y coordinates?
It's talking about which way, it's talking about matching it up to where it accelerates. It's accelerating this way, isn't it? So then could I,
Should be.
could I set it up like this? To be this way here?
Yep.
Yeah, and then this way. So
It turns
I
out
could set up, this is gonna be the complicated part. Making sure that I know that this is positive for Y and this is positive for X.
I'll let you go back to your spot and figure out that, and then I'll continue and you come and ask.
Am I sort of on the right track? Okay, awesome.
So I believe
So
these,
instead.
because if you have theta, the extra.
Or are you saying, the exact opposite of this?
Great.
Nothing like this.
Okay.
I,
Alright.
the acceleration,
Wait, so,
the
so this way is
extraction.
the.
Yes.
So the,
That way would be the
Perfect
other.
modifier.
so what will the acceleration be at that angle? So that's something that we don't know, because your X direction is the direction of where they're accelerating to.
So do for
I
this,
guess I
do I
guess
just
you
put
just put.
Right now you can just kind of put a question mark by it, however you want to mark that that's an unknown. And then
So pay attention to
S,
this ain't
negative,
so that's directly down.
using,
And then
it would be the static
go
friction.
to the normal.
right.
So you're trying to overcome static.
So yes, you want to start with that, and then you'll have many steps.
And perfect.
Yes, and then
So it's not-
S,
So the angle is wrong.
Be negative for both X.
right.
So this would be no change.
Friction Y.
Alright.
Yeah, because that's on your x-axis, and then F normal on the y is F normal. Yes, and then
So that's normal, we're gonna
So.
the,
So this is this direction.
but my unknowns here are,
So we're wanting to just
theta,
like
acceleration.
how it's drawn. Okay.
Yes, like that.
Okay, so if it's that,
NG sine theta.
Then that's what you're drawing.
okay. But
So
in this direction, it's not.
you need to
No, the force gravity is one.
I guess you can keep your letters. I'm so used to plugging in numbers earlier than he does.
This here.
So
Just the same. The way I do it, this is essentially like that.
so you got
So you
one.
can have this arrow for this arrow for this arrow.
And then if I plug this in, I would have two.
Okay, so this way, if this way, if this way is acceleration, both of them, just like both like all this direction.
Okay, you wouldn't call this call this like one. Only when it was toward the center that I called this one.
Okay. Okay. But either way, it would
And
be.
then make the equation
I'll come back to make sure you have it.
Alright.
Well, everybody's raising their hand. Excellent.
In the first problem that we did today, you solved for K, which was another coefficient, and that helped you solve the rest of it.
Oh,
Do
okay.
anything
This
with
here
that.
is the.
So
It's for the situation.
sorry, I'm not having a chance to actually look through the problem before you guys ask questions.
That was just a free constant, but
So
with this,
0.5, we don't have the distance, so we can't find that force. And I'd have to have you ask him, because I haven't been able to work that far yet.
Acceleration in the y
Let's
direction.
see what else we're missing.
The force of gravity. Force of gravity is moving. Where that's the y direction.
And
So that's where we need to draw the triangles like I was. So go ahead and draw. Yeah, that's what I'm gonna have to do, yes. And your energy is vertical, so.
sorry, give me a second to fix this.
And then you start at one, and you go on, and you go parallel to the next one.
Honestly, I might have to realize this. It's not happening in my head right now.
this one is wrong. It should,
You have to set this equal, so it can overcome
Like it's a Z well round, it's not a.
equal.
I've made that mistake many times in my life. Okay, so look at his. That's what I want.
Okay, I have a, so in order to secure
No, that's fine.
it makes, okay, kind of some sense, we have it done in different ways. But I'm assuming it's because this needs to be the most structured.
So, I mean, you could draw, whichever, like, it could technically also be,
So we had this, we had this. And it was
okay. So, when you're setting this up,
So then
you
can
want
say, okay,
one of these to be in the same direction.
There's acceleration.
So that's
So really it needs to be this way.
it's parallel to
Their acceleration.
So, with this, you're accelerating on this incline.
Then final thing.
So, So yeah, so it would actually be just the opposite of
Oh, wait, no, I'm looking for, where's the angle?
Oh, so it would be.
I want to say
this.
that your actual kinetic friction, that I said that wrong, is also gonna be this. I have to double check just because it's going so long. I've done some kinetics and it's actually yesterday.
Because if you don't adjust that,
This is better.
But your A is going to be more at this angle. And so that's why you want to set your axis to be like this, rather than, and then your Y is because it has to be like that.
Right, okay, that makes sense. So you're thinking this, the kinetic friction?
Yeah, I think it's actually just your force of friction in general. And then you'll have to like basically just do like your friction.
Does this look okay? So this is one that's, do we even make this?
So let's back up to here.
This is wrong now, so.
Okay, so looking at your axis again, redraw this now that we've kind of discussed that. So what is your actual axis? Do you need this data is what I'm asking?
No.
You're good.
Okay, so this goes.
Okay.
And that's the way.
now we'll check that question.
Yes.
And then this will go like this. We do this.
Hold on, you're done. Okay. What's the relationship between your force of friction and your force of normal right here? Are they at an angle from each other? Are they perpendicular? Are they? What's the situation?
They're not perpendicular usually.
So they are actually. So you're accelerating down at this angle, and so your force of friction is within the same, axis. Your force of normal is always perpendicular to your object of interest.
That's not correct.
So you can actually remove this theta piece, and your force of normal is sitting on your y-axis.
Exactly.
Mhm.
But that would make this.
So right now what you're drawing is this straight line down. That's going to be the opposite of your force of gravity. Does that make sense? Otherwise I can read it.
Yeah, I can see how you have it here and then.
So the reason being is that this dashed line would represent what we consider our normal y, but we don't have our normal y-axis. We've tilted it because our force of friction is at this angle. It's not in the strict force.
Oh, okay.
And our force of normal is always perpendicular from our force of friction.
This was correct.
Yeah, so you have that, but you don't need that theta in there because it's sitting right on the axis.
Well, I'm looking like I did before, put a top.
And then our force of gravity would not
It
be
gets the second part to the top.
on like this.
No, because it's not opposite of your force of normal. When you look at your diagram, yeah, it's just straight down. So if you draw in that dashed line, I would say draw in your dashed lines from your force of friction and your force of normal to finish the axis. So continue down here and then continue this way. Yes.
So we don't technically don't need this down here. This is like what the kinetic force.
No, you don't need that.
So actually what I can start.
No, you're
So
good.
now that makes more sense. We need to kind of do that. Are we on it?
So draw out or write out, you can do it in here or wherever really if you want to do it up here. Write out what your force of gravity will be. Why would you do percent theta for your force of friction?
Well, no, we don't have.
So right now, it's really hard to like understand this concept of the tilted axis, which I get. Your force of friction is sitting on your axis. So your force of friction is going to use an S, force of normal. Multiplied by force of normal. Your force of normal is just force of normal. Your F of G is where you've got to find the X and Y components.
Okay, explain that again.
So your axis is at this tilt. So you're sitting on the x-axis. So in the x direction, your force of friction is just your force of friction. You don't have to account for an angle. Right.
But for this, we would have to.
Yes, because it's not sitting on your axis.
So that would be our. Where else? So sine theta and times G.
So draw out which ones would be your x and your y. So let's do it. Okay, so you're looking at this here. So this isn't really parallel, but it's fine.
Usually, I mean, the strategy
Apologize. Make this bottom line more parallel with the x-axis to understand that it's an x. So this would be.
So what would force of normal? You don't have the wider time. Static is just force. It's not like
This is our. This line is our force of gravity. This line. You need to find out what this is.
What did you figure out?
I just want to know if I'm doing this right.
You're kind of in the same spot as she is?
Yeah, I'm in the. Well, actually, yeah. Because, see, I understood how to do the other stuff. I still struggle with knowing where to put it. But,
Right.
like, did I even do that right? Like, that's still the same thing I struggled with when he did it.
So when you draw your F of G,
And just drew it, like.
I would draw it the same way that it's, I mean, I guess you can do it that way, that's fine.
I noticed that it was a little off, but, yeah, so if I do it like. If I wanted to draw this bit, then, would it be right to do it like that? And then it would go like this, right? Here. Sorry, it would be this, right?
Sorry, let me look at your it's different. What are you doing with your coordinates?
Well, I was like, okay, well, acceleration is this way, since that's what I need. So then I just define force normal as being force friction.
I'm applying Newton's second law,
Okay, I'm just gonna.
but I have too many unknowns.
Yes.
So you used to say that.
Yeah, like that, yeah.
So you can do it either side. You can use this line or you can
It
use
doesn't
this line.
matter? What the? So I could draw it this way, like that's the thing, would it would go this way, right? And then it would go down.
So is this?
So when you draw your, when you're adding a vector, you have to do tips.
Yeah, because I saw him do something where he started from the table and then that was when he did up there. So that's what confused me a lot. Like beyond a lot.
So your force normal
Oh, I'll put that.
is angle right here.
Yeah.
Basically, I didn't use
is theta.
Yeah.
So if you do this, you can draw this line right here
Yeah.
as your y,
And then we go this way.
and
Or
your
use for gravity?
Yeah. So would it have been wrong what I did over
That's
here?
not gravity.
Like when you.
No. I mean, you would
So
just
X
have
is
to
what
get
this is different.
So it'd
Oh,
be
the angle? Well, when I looked at
this
this,
way and
It's easier if you just
I
keep your
figured
angle,
that
like
this is
draw
theta, right?
your force of gravity off of the
I included
angle.
that.
you wouldn't even.
So when
That's
you do
theta,
this,
the
okay,
remaining
so
That's the
since I drew my axis.
Oh, so here. Wow.
So.
Oh,
Yeah.
you because you see yours.
Yeah, that's why I keep
Okay, that's pretty.
So when you do this, you know
Oh,
that
this is 180.
your F of G, the angle is at this point. While you could, obviously do it whichever way.
Yeah, because the whole thing has to be around
Yeah, because technically you could
So whatever this
draw
is.
this way.
Wait, but I'm sorry, I'm getting a little confused.
But that's okay because if I draw my picture here, this is
So
the angle
your
between
angle is right here.
and
Continue to draw
here
your dash line
is
for your
theta.
axis.
So that would mean that would just flip what I have.
Yeah.
So that means that the y component is the
And
cosine
then I would go up here.
and the x component is the sine.
Does it just keep?
Nope, just,
Yeah.
I mean, your axis does.
Yeah.
Then you just draw your line.
Yeah, so it is.
And then it goes on. Okay, so technically what I did here.
Well, basically, let's just say that this is supposed to be normal.
And I made it like
This.
that.
You can
That's what I
rotate
have
this
to
way.
do. How it was before.
So now, like
So you're
everything
gonna
that I
have to
considered
shoot
y
your
and x
direction because you're
are
not adding tip to tail. When you draw your triangle,
So then why is this one considered tip to tail then? Because it's like,
because this is
And so that
your,
means that, f of g
this is your A, your B.
is supposed
and then if I
to
would have done it from this side, how do I do it?
Yeah.
Yeah, that's what I did here.
So what you did over here was,
But yeah, no, my problem is like it's not easy applying it. I guess.
so are you saying that this is your F of G then?
And
Yeah, that's my
Oh,
F of G.
so you
And
don't
then
do
this
that.
is.
I thought you were doing your X.
Oh, no, that's.
So
Sorry.
now just solve for your X and your Y components for F of G.
Okay, but we don't know theta. That's the thing. So then would I just do the inverse?
So for right now, do,
Yes.
Also, just write it in here.
yeah, just write it in.
Okay, so I do that, that would be my F of G, and then I still do like sine and cosine whatever, and then I just put it in.
Yep.
So it-
And just write it in your box.
Okay. This is the.
Or some friction and x direction.
This one,
So
so, this one is not in So, this is your F of gravity and your X. And this is your Y.
that would be negative because it's positive.
And they, sometimes it's easier, yeah.
Kind of, but you're actually my y is right.
So, and
See
then
that?
your angle,
So therefore, whenever I say x, I mean y.
like this angle. Yes. So technically, I can do. This would be my hypotenuse. So for which one? I mean,
So I'm assuming like the images are going to cancel out.
so would you use sine for your X component or your Y component?
So the ends are going to cancel out. But that's going to leave me with f of n and theta.
So here's your
Because I don't know
hypotenuse,
how to get
and
past
here's
all
theta. So theta to find your X, which is right here.
So with the opposite.
So you're gonna want to use unknown value.
Yeah, because we don't know the
F of
acceleration.
G is your known value, which is your hypotenuse. So you're gonna use opposite for the hypotenuse.
Yeah, because if we do this, it's really easier here. We don't know what the net force and acceleration is.
Okay, so draw this and stay in your F of G.
It's like the gravity now.
Is there?
This is just your F of G in general.
Oh,
So when we go back to,
Yeah, okay, that makes sense. This-
Okay.
Yeah, when we drew that.
so
Let's simplify the unknown.
your X components of F and G or force gravity would be
This or that.
yes.
Which is sine.
Yes.
So, sine. Say that.
Right, that's what and so then if you
Yeah,
ever
we-
So is what you're gonna do
I have all positive.
is to find this, you're gonna put FG equals MG times sine theta.
Are you still using the same thing? The same picture here?
this is a different.
In that case, all this should be
Which if I have that.
actually it is.
Yeah. It just puts it all
yeah, your first
into pretty much
friction
your X component is.
is doing-
And then you wanna make a note that this is, yes.
So
Then should I do FG as a y as well? And then that would equal. Can I use both of these?
So you'll wanna use and set it up as your,
So this over.
We're gonna have to take it during.
and then plug that into your
So like I
table.
said, it's really important.
Or yeah, things.
Lydia, where are you?
Okay, yes, I was gonna say, I was gonna explain because I think
That thing out.
but I got that. Okay, so, everyone's drawing our diagrams, just throwing me off. Okay, so,
This is theta,
yes,
which means that this equals theta, which means that this is not theta, so my drawing is wrong. And so this is theta. And so I changed it so that I made this. This is theta, correct?
yes, that's what I have.
Yes.
Perfect.
Okay.
Okay, so then,
And I changed this so downwards is positive.
So.
and that works. You can do it whichever way.
So, this would be
See, it's happening over
negative
here.
Positive. And then let me make sure that you're, yes, I was gonna say, for some odd reason, mine came out different from yours and I didn't notice the difference. So, we've got,
sine
okay, so you did it right, yeah. Perfect, and G, theta,
Because like,
and then negative.
it is.
Okay, there we go.
So, and that was made because I changed X to the negative,
Yes.
zero,
Well, oh yeah, because you know that you got it.
So I think I fixed everything, correct?
Yes.
And then,
Okay, and then yes, back to. Everything crossed over.
So this side here is adjacent side. This side here.
this one, zeros.
We don't have the extra. Just extra.
You took off a G right here.
Down to the left part, that is down to the
Oh,
left.
that's here. Yeah, that's a G.
Yes, otherwise,
Where was the other?
yeah.
Okay.
Yeah.
Now I'm filling in everything, this is the correct.
You do that.
Our epidemic would be the same.
So with this, look at your axis. So this is on your y-axis, and this is on your x-axis. So when you're looking at the x side, do you have a force of normal in your x component? Okay.
Okay, so.
And then for X,
All right, there's a lot.
Okay, so then we'll have one.
Okay, so I just think like, I feel like I'm putting twin zeros. What is the force, is there a force friction in y direction? Not that I can see.
So you look at the
Yeah,
there's on the y-axis and the x-axis.
we have force normals on that one. On the y, that. Yeah, the force normal, I don't know what force
Okay,
normal
guys,
is, right?
Right.
So this is my unknown. There is no force friction in the y direction.
I know.
Yeah, so the acceleration in the y direction, there's no acceleration in the y direction.
So you're going to accelerate in your x direction.
Yeah, that's not extra. So then there's no acceleration. So then if I'm setting it, I just want to make sure I'm not like, also, I don't know what acceleration is here.
Right. So you're solving for that, and that's part of your.
Ooh, okay. No wonder. I was like, I don't know what to do with myself, so I don't know that. And then force normal in x direction is 0 because there's no force normal, and the force of friction is just what is given.
Mm-hmm. So it'll be your force of
This one here.
yes. So what are you gonna plug in for that?
Just the number that they gave us, the static friction.
Yep. So your mu sub s
Yeah.
times force.
That's wait, what? This is what force of friction is? Force normal times this? Oh, so we need to figure out force normal first here, and then plug it in
Yes.
over
So
here.
you're gonna
Sorry, I just want to make sure I'm doing this right, because otherwise I'll literally sit there and be like,
No,
oh, I need to
okay.
wait.
so you're gonna do your sum of your forces.
Which
So you just plug.
would just be like the force normal plus f of g cosine theta. Also, did I do that right?
Mass gravity
Is gravity, is there supposed to be a gravity here?
Yeah. So you're gonna have a gravity in both. So
Okay.
you're gonna have your x and your y components of it.
Which that's what I got, like opposite sign is in the x direction, which is the
I'm
phi.
sorry, I have to look at your diagram.
Yeah, go ahead. Wow, you have to switch and switch, huh?
This is our first draft.
There we go.
divide out mass and gravity.
Okay, so it's just.
So why don't you do that direction?
G shouldn't be.
Why don't you do it?
So here's the deal, minus, you can sign it, but that shouldn't happen.
Yeah.
How we have this, shouldn't happen, how we have a negative.
Yes.
I have to pay attention to.
However, this is.
Oh, wait.
Yes.
Okay, so then when I have this part here,
So when you plug this in, FG, when you put this in your table, you want to know that FG here is actually mass times gravity times the second theta.
oh, sorry, oh, yeah. I remembered I needed it, I was just gonna put it later, but I should probably put it now.
Yes, otherwise you will screw yourself up later.
Okay, so then this one, I just subtract it over, so it'll be negative f.
Once again, you're gonna need to plug in your
So
Oh, this is this way, yeah.
and whatever your direction. So which coordinate system?
So then this one would be negative here in the x direction.
Okay.
Would be negative here. And then in the y direction,
Which is, oh, I already reported, 0.
negative also. That's what I got.
So I just need to
Because
understand.
my x is this way, so.
Okay.
So what tilted, yeah.
Yep.
So then.
So I'm gonna have you erase this at some point.
Oh, yeah.
Otherwise.
I'll actually erase it. So this is the way I have it. This and then x. So then. Y and x. So then, if it's going this down, then it'll be negative because I've identified y is up here.
Right.
So then that one will be negative, and this is going this direction, and I've identified x this way, so it'll also be negative. So this one, that will technically be negative here.
I just multiplied.
Yep, so you're gonna do the force of normal minus your MG theta
And are we giving them that? So?
It's gonna be one of those problems.
Oh, you got it
It's
all?
gonna answer that.
Gonna have that it does? So then do I just, so is this typically together, you just add it to the other side? So force normal, and I just plug it.
Okay. So we have our force I have to go look at my watch. It's a shortcut.
So.
It's a good measures. You can measure static friction by taking a book or something and just stop. And so you get an angle to start moving, and that angle tells you exactly what the static friction is. But you should be able to draw it off that here. But what he's going to tell you is that would be the first one.
He's like, the exam
Okay. Then once you have the angle, then you have to do the calculation based on kinetic. And there should be, you make your axes in line with the angle, or you make your axes.
Now you're gonna get down to this portion.
So axes are
And the second one is you're gonna start doing some.
But it seems like it's more
Right, so I have to check with him because he didn't give me the problem before you guys, so I literally got it when you guys did, so I was going to calculate through, because so far what I'm
So
seeing
it looks
is
like we get the
that
same result in this
you guys get to the force normal,
because
and then
I
you're
would
gonna
say
plug that in, and this other side,
X
because stealth
direction.
beta and acceleration is unknown, and so I have to not be able to get to that point before you guys have. So start this process with doing your force normal and solving for that, and then getting over here and plugging it in, and when I finally get a break from questions, I'm gonna ask him what that stuff is afterwards. I haven't been able to look at that yet. So solve the force normal.
Sorry, it's zero. It's force equals mass times acceleration in both of them. You have to separate them. She'll tell you how to do it, right?
Okay.
No.
every word that it says.
I know you unfortunately haven't been able to check on that yet, so let me check and make sure that everything else Okay, so let's back up.
Oh, wow.
So tell me what all your forces are. I've got to be up and down, like I'm Okay, so when you set up your axes, what needs to happen? Right.
Yeah.
So is what's happening is your acceleration is happening at this angle. Shift yours. Yes.
That's exactly what you're supposed to do.
So is what you do is it shifts all of this. So you can make your coordinates like this.
So what was your question?
And so that means that your force normal is on your y-axis. Your force of friction is on your x-axis. Okay. So does the reasoning for that make sense, or do I have to use it in that?
Square root x squared plus
This would be a negative friction.
So I applied that.
Yes, and do you understand why these would then lie on the axis? Yes.
That's correct.
So then is what you're gonna do is I'm gonna have you go back and draw this. Your force normal will only be in your that direction. Your force, like your static friction, will only be in your x direction. You have to solve for x and y
So,
yes.
now this is square root
Yes, of course.
square root 1 plus well, this is remember your formula. Yeah.
You got it.
I've got this so far.
Yeah.
Is this clear with the math can cancel out here?
But
Because I don't really understand why. My algebra background's so weird. I'm like,
So yes, so.
Because you'd be dividing it all by masses.
No,
No,
you just divide both sides. So you cross out all of your masses.
So for now, right?
Divide everything.
Oh, wait, did I plug in sign data? Yeah.
But that's why I want to cover, because if I divide all that by hand,
We still do.
yes, because we didn't know. So that was, we had two variables. Now we only have one variable. We still were looking. So we just put all that, and then whatever that last number is.
What did you get? Because I finished yours. I got theta of 11.8.
So why do you have this MG?
Oh, it's because that's when you have to add. Oh wait, there is none. Oops. Okay, I'm glad. So I come up here.
Oh,
So the
I know.
here anyway.
That's pretty close to what I
And
read.
these cancel out. So yeah.
I didn't like put in the actual thing. I just wrote like
Out,
26.
so then you've got this one, yeah, so it's
Do you have the same equation though?
So then I divide everything
Yeah, I
out about the m's.
Yeah.
And so would we be looking for acceleration?
So,
Because we don't know acceleration.
so we don't know acceleration, and we don't know the static friction.
Wait, I thought-
Or we know the static friction, but not your, what was it? Your theta, sorry.
Yeah, and we don't know theta yet.
Yes, so I have not been able to get to that point yet in the problem, so I have to either ask him or work myself to that point in the problem to be able to tell you what you're going to say.
So
That makes it.
since it gives you
Well,
this
no.
coefficient for static friction, you can have it so that you
Because then you
can
have.
solve for theta by making acceleration zero.
Yes,
So-
because it would not be moving at the point that it's, yeah.
So you have
if you
No, I just didn't get it before last, sorry.
From the wide area.
I have not been able to finish it. I would check and see if you see how it's looking.
We don't need to.
I mean, we got the same thing, so we did it right.
Because you have mass.
Yeah, so we set the acceleration equal to zero and
You
use
have mass on
So
this
that
side.
you have.
Yes, so you would set it to 0, solve for your theta, and then you do like the fun
and
factor.
then you did the same exact equation but with the kinetic
So
equation.
if you
Yes.
divide mass on both sides.
That would be the step to doing it. So I don't know if your answers are exactly, let me make a note of your answers. And when I work through it, I will,
Both of us have the same.
I would assume that you guys have
Oh,
the
well,
correct
there's one step I skipped over. Just back that up.
Yeah, I didn't understand.
Alright, so this whole thing right here.
First part.
Just make sure you didn't miss any signs or anything.
At what angle?
Yeah. So I can factor out.
So she needed to multiply now.
So first part, 9 theta.
We have to multiply 9 theta
Minus coefficient of
Also
kinetic
get rid of the G's.
G. So it's 9
And
theta.
Sorry.
cosine theta, tells me some S, theta, and then inverse theta. Yes, that all looks like it's fine.
And so it's the
We're not
coefficient.
gonna do this using this.
Yeah.
So,
I understand.
that,
And so now there's only
Now we
one.
need to pull it
and then we can
You
also
can
factor
factor
that.
and that's why.
Theta minus.
So you need to divide it out. I move, put time over to what's negative.
Well, you have zero, so since you have G in both.
I got you. I don't know.
For this first part.
That looks correct.
And then so you divide it times one side.
And then, yeah, I'll write it down. And then
And you're still leaving graphs.
Interesting, thank you. Yep, you're good.
So far I have it down to this. So I'm just wondering, she said it's 0 because at that point he hasn't left, he hasn't went down yet, so I just wanted to know the angle.
So if you're static of friction, when you've still got to that point, so when you're talking about your minimum angle for a child to overcome the static friction, if we're saying that they haven't overcome it yet, then they're not accelerating.
So are we just supposed to know and assume that?
Yes.
So how does that happen? Because I would look at it and I'd be like, okay, and I'd get to this point, and then I'd be like, okay, I don't know what to do with this stuff. So, and I didn't know what the acceleration was. I would have predicted that they would have already been going down the hill, wouldn't they? So they wouldn't be accelerating?
Okay, so at the first portion, when you've got a static friction, they're not accelerating. It's keeping them in place. Once you have a kinetic friction, it means that they're moving.
Okay, so static friction is trying to keep them in place. So then
It's trying to keep them from sliding down that hill.
okay, so both of them are technically 0 then?
So it's 0 for the first portion to solve for your angle.
Yeah, and then later you'll solve it for something else. Okay, so technically this is 0 also. This whole thing is just gone. Okay. 0. Okay, and then now that I have that set to 0, all I need to solve for is the theta.
Yes.
So, do I plug in the numbers first just to see what it is?
So
Like, when should I plug in the numbers? That's what I'm wondering.
So here, I would continue to solve so that you have everything set up to what theta equals, and then plug in the numbers.
How can I go about that? That's still something I'm like.
So with this, you can add over theta, or add over g sine theta.
G sine theta. Sorry, my mind has to put all of the steps literally there. So then you end up with is that best? G cosine theta. And then have that. Okay. And then would I just so is this work I can do?
How do you want to get theta together?
Both of them? Do I move this over also, or no? Or
Which portion are you going to move?
Cosine? Oh, this one or cosine theta?
You're going to bring your g with you because then they'll
The only
cancel
difference between my equation and yours is cosine.
So I multiply it.
out. So you're going to divide it.
Oh,
Because
that's
they're
right.
multiplied by each
They're
other.
like this. Okay. I knew it. I literally told myself, like, should I go in parentheses? The other way I know that I should divide it if I needed to.
I would keep them in parentheses because it makes it more clear.
Yeah, because sometimes I'll put things in parentheses and apparently they're not together, and you can move. That's why I don't do it because then it confuses me. But now it's confusing me again. So oh well.
So apparently, whatever you give it, you're gonna actually
Then that's when I.
like all of your math is for Maxim. Apparently, my
And it's here where
rules
these cancel out, and this is just tangent. Isn't it?
Yes.
So if you could do mu sub s equals
your math
theta,
is fine.
yes, and then can I do the tangent in the first one?
Yes. And plug in for your
That or
I'm gonna do this and then I'm gonna write.
you can, I was going to say you can do it on the back side of the page, you can do it there at the bottom, that's fine.
No, I'm just gonna get a separate sheet. Does that work also?
so because the catch is
Just so I don't have to
your
turn it around.
that's what it is. Your angle should be the same as our angle.
Do you have questions over here?
So your angle should not be the same as our angle.
As far as like calculus physics or actual calculus? Okay, I'll let you continue solving for that.
What did you get if you put it in the art space? Or whatever thing you did.
It's not a physics calculus motion.
Because if that answer is this equation, and if you use this answer,
It has
we know that
been
your angle is right.
5 years since I've taken calculus. for this, so.
Where's your so I know this is.
And assignment related calculus related is like,
Yes.
does this mean with?
Oh, okay.
Oh, the art.
Right, just another double check, understandable.
Let me see. Essentially what you've done is you've taken your angle.
Well, I'm so picky, I'm sorry. This stuff is causing nightmares before.
Okay, just got.
It's actually like you're still with this.
You get the signs on these numbers.
So, tangent inverse of, and then I would plug in this number here, which is 0.2. Static friction and it's equal to data.
I was on the right side, and then you can
I actually understanding the same.
Whatever the static friction one.
No.
0.03.
I can't find my graphing calculator and I've been using my friend's and he needed his today, so.
9.8 times the cosine of 0.006. The first minus.
Thanks, Sarah, that was a big one.
So I got 11.859. Does that look serious?
Yes.
So this is for the first part, right?
Yes.
Oh.
Now you're gonna.
Yeah, 9.8.
Now I can actually plug this into the actual thing, but except acceleration will be 0. So will it just literally be all of this thing after the end's been gone, but acceleration is not 0?
Mm-hmm.
So can I just write that out? Like, will he drop me off if I don't rewrite everything?
I would rewrite it.
Okay.
I'm not the one grading it, but I would rewrite it because then you'll understand what you're doing.
Okay.
Like when you go back to look as you're practicing problems, you'll be able to understand why you're doing that.
Okay. So then I'll start off again with the mu sub s, then mg cosine, and I can put the actual number in now, or do you tell me this?
You can put the actual number in.
And tutoring, can you go over drawing Freebody diagrams?
Yes. And then did you figure out this one?
I did. Yeah. Once I got back there, it was like, it was this.
I just didn't get to
drawing
actually
it
look at
was-
the question to.
Yeah. Drawing it was the hardest part for me.
Drawing it was
and
definitely the
weird,
hardest part, and I think that.
because they even had something different back there.
Right. Like literally everyone has drawn it differently.
And then it
That
gets
it's
you
like,
confused.
right, you have to really make sure that you're drawing in your lines to understand where your arrow's gonna like switch to. So yeah, we'll go through.
I know that's something that even Emily was like, that's what I
She-
struggled on.
yeah,
Because
I
once we
took
got
wrong.
into the algebra part, it was like, that makes sense.
It's
Just drawing it. Yeah.
we'll draw something like that.
The question number, the last question in the homework is drawing a Freebody diagram. And I struggled on that. The one that was assigned yesterday. So homework 11, I think it is. It's the most like, the one that's due Wednesday night.
So Wednesday's tutoring session will be still from 7:30 to 8:30.
Okay.
I was gonna say something about the beginning of lab, but I didn't get the chance to. Thursdays will have to be a different time. If it can be like 2 to 3, I don't know. Do you guys have stuff on Thursdays? I can't remember.
But
I wasn't sure if class-wise you guys had stuff. Okay, I'll just send out something. But yeah, we'll go from there. Perfect. Yeah, if you have any other questions, like things that you want to know tutor session.
And remember, Scout, she's available what are your times?
So for this week, and I'm gonna send out a little Moodle message for him, that kind of thing. So Wednesday, I'll do tutor session from 7:30 to 8:30. Thursdays has to be bumped up a little bit earlier, just because I have clinical at 3:45. So I'm thinking a 2 to 3, but I'm gonna check and make sure that works for you guys. So on Thursday, just for this week. Usually it's 3:30 to 4:30.
This won't be kinetic. This won't be kinetic friction now, right?
Yes.
Okay, I saw. I was like, wait, it's not gonna be static friction.
So when you do that, what I would do.
I think across my mind.
go through that.
Yeah, they might.
Oh, and then we show what it can do with that.
So
So
I
you've
get
got,
put
this is an unknown.
But here's where you put correct say fix, so that's.
Okay, so I could
Okay,
show
so
you
I'll
mine.
show
Can I
you.
say second part here? Just like that. And just be like, this is unknown.
So the inverse
Unknown.
would be our correct.
Okay.
Yeah.
And then
I
the
said, can I leave
fourth
it like that there, or
section
should I also?
will be equal
Yeah,
to.
put boxes.
Oh, that's what I forgot. I forgot the normal force.
And then she marks out, she
Oh, wait.
correct say fix right there. If it's
The normal force is,
Oh, yeah, that's right. Okay,
it will
so.
be-
but noting that it's your,
Um,
that you're, going to use the kinetic.
Oh, that's, yeah. Kinetic. And then it would still be times force normal.
Yes.
And force of gravity would still be.
And then the
equal to
quiz.
negative.
And then we don't have to do the quiz, right? Okay.
And then force normal x is still equal to.
Emily, did you get the same numbers?
Okay, I got, so then with that,
I got 15.
I just plug in the numbers that are here,
Yes.
and that's the answer?
Mhm.
Yay! Gratitude! Yeah, I feel like, I don't know, for the longest time I didn't understand Freebody Diagram. And
We'll
then,
go
like,
through, will you be coming to the session on Wednesday?
Yeah, I mean, it makes more sense now, because I mean, this is like my second round going with physics.
Right.
Yeah, so
So-
then it's been clicking as time goes on, but it's still beneficial to go just to make sure I got it.
Right, so we'll do some kind of more difficult free body diagrams all in
That would
the
be
agenda,
great. I
just
want
because that
difficult
seems to be an issue kind of all around that, like, and that is, one of the biggest things to understand because it completely throws off the rest of your problem if you do it wrong.
Like, I feel like I got the ones that have only like 3 or 2. I feel like I got that, but I want like a complicated one. When you get the complicated one, you get it.
Okay, what do you got for us?
That's what I got.
So, and then you rounded your significant digits? Yes, that's it.
That's what you have?
Yeah. And then,
11.
what'd you get for your theta?
11.
There we go. Now we're good.
You're welcome.
If you do that, it will say 78 degrees. But because yours is right here, not right here, your 11 is 0.
We turn the last 2, right?
So you'll turn those in, I guess, I don't know if he wants you to submit them in paper or if he wants them online. You might want to ask him because I'm not sure how he's doing that.
Oh, yeah.
I feel like that actually makes sense. What is going on?
I would go through your supplemental homework
Yeah,
and find another.
which one would be helpful for this?
I have no idea yet.
See, that's what
I
I'm
don't know them off the top of my head.
Because I haven't done any since, so I done the first one since, the one after the exam, but I haven't done the rest of them.
I would go through your supplemental homework and find another problem like this and do it tomorrow.
The one
And
that involves static friction and kinetic friction?
yes. Find one of those, give yourself, the rest of the evening, do it tomorrow, do it without your notes, and see where you can get. That's what really helps to make sure that it sticks in your head.
Yeah, so it should be out. Which is also, because I took A cotangent and it's 78.
Okay.
So it was.
But we need to, but look at the drawing and see why it's because if your theta.
Well, he hasn't been using that value.
You're
He hasn't
using
been
it.
using 78. He used
Yours is over here.
0.036.
Mine is over here.
But we're both solving, and your theta is.
Yeah.
So if we solve for theta, it's just
Our theta is 10.
No.
Well, she's saying they shouldn't be. She's saying they are. What they should.
So our theta is.
Like, if anything, you should just have the negative theta.
And so
not supposed to be a negative number.
It shouldn't be.
Alright, I need to grab
Not a
some.
negative somewhere.
I'm just gonna take.
Unless it depends on the way your axis is set up. I would assume that you'd have put your acceleration to positive just to make your life easier, but.
I did not. The negative would
Give a question, is that what you're gonna say?
Yes.
okay. So
So
negative would be right.
he drew his analysis.
Have you guys?
You're killing me.
Okay, because, yeah, I got the angle already, but I'm just wanting to check if I got the answer right. So there you go. What did you get? What you got? How did you get it? Did you get the angle?
I mean,
And so we found data for him to
So you wanted to do that.
but then that's not the same data that we got. And then if you 90 minus that, you should get the same data.
and then what else is like?
So, it's probably the way that this ended up in your free one, because I've been seeing a lot of people have issues with it. So,
Well, I mean, they use this to solve for your force normal, and then you take your force normal, and then you plug it into your force normal on that
where
side.
do you have?
I mean, you got right.
What's your,
That's the angle. And what you do with this angle is you get this angle, and then you plug it back into what you asking for force normal. Did you look for force normal?
Right, so
and then,
Yeah. So force normal. Did you identify force normal?
so is what you wanna
that's
do
why.
is you wanna make this your
It would have
hypotenuse,
been.
yeah,
so
so
your F, like your force gravity should
One of my
be
visions
on
was-
this.
That's what I already did.
So,
Well, yeah, so
minus
I think most people did it like.
But then I
Yeah,
said,
if you did it, that's okay.
oh,
Yeah.
okay, sorry about that. Okay, so what I just did is, since you said because I just, did the forces on the y side, and then I ended up, manipulating the force normal on its own. And then I ended up with mg times cosine theta.
that's why.
Oh, we know.
Okay, so that's your estimation.
And then you did solve for the gravity, right?
Okay, so that's your
Straight
issue.
down.
Oh, okay.
Okay, so
And you probably
when your
yeah, it's
theta
probably
is
because
initially
yours is a little bit
here,
why we did it different.
that's like,
So, what I just said is I say this way, is once you find
Right.
the angle, just
so
plug it
if
back
I
into
put the
your
shape
equation,
set up,
and then you should have acceleration.
so
Not at zero, but actually.
here's your X, and here's your X.
Like, you know what I mean?
This
Like,
And
is
then,
actually, let me see what I did here.
So, okay, so I just do that over again, hit this section. That's,
You just do so different.
so you make this your Y, and this is your
Okay.
X.
But all I did was like,
So basically what you
the
did
angle that I had,
is you set this up,
you know how acceleration zero here?
Well, I just use this
It won't
right
be
here.
zero in a second, probably zero. So then you're getting the acceleration.
okay, for a second, I'm sorry.
But I'm just gonna
Just
plug
to
in
make
your
sure that this paper is on the same side, because otherwise it's not flipping it again.
But then
Because I think you put your theta in the wrong.
Okay, so now. You're going to replace the acceleration from zero is your unknown.
I did.
And the coefficient, so
The
the
triangle is
Well, I
always
know that with this, you plug it back into the
coefficient.
yeah.
Because now you know what the angle is, now you're solving for acceleration.
Yeah.
Wait, but I was actually sure with your
So-
Which is the one that you did.
They wanted to see, you know?
So it's what you're
Oh, I like that.
So
You want to
okay,
put
so
it on
you
this
set this
side.
up. So the way that you set this up, this is theta,
Yeah, if you could, that close,
and
that's
this
the
is the
reason,
equivalent
would make
theta once
sense.
you.
Oh, alright.
So then this would be
So,
45
Yeah, I would ask-
minus theta.
yeah, once you have that
So-
angle, you just plug it into your theta.
Your theta using right here is complex.
Alright, which would make sense, because that would.
Force normal is
6
36.
side.
Yes.
So we just.
Okay.
So we can change it.
Yeah, so are you coming to the tutor session? Because we're gonna do free body diagrams and we're gonna look at the difficult ones. I'm gonna find some difficult ones. Just
Mine ended up with a negative, and I think one of the reasons why is because I set my X to distraction and acceleration is one distraction. But I don't know if I got the right answer. I feel like, I know I did this general processing. So does the way you solve the problem vary from what you put your X and Y as?
There are sign differences. That's the only.
Like negative and
And so
positive?
again, yes, you have a negative acceleration because it's going opposite.
Yeah.
So it's still accelerating down, which is the right answer.
Okay. Okay, well then I'm just gonna wait for her, she has the right answer now. I just want to make sure.
I was gonna say, one of the biggest things is really trying to draw those free body diagrams and creating that consistency when you go from your physical to your free body so that you make sure your theta makes sense. Because otherwise, it's an easy little mistake and then it obviously throws everything else in the bone. So, where do we have that? I have another one. I'm not sure if you guys are doing them in Moodle or if you're putting them just in paper because people just left their paper. So I'm not sure how you want it.
Oh, actually, these are mine.
Oh, those yours?
Yeah.
Okay.
Sorry, I'm such a like
tools like submissions of their assignments. Yes, copy them and put them in Moodle.
Okay, so.
And for yours, if you want to,
So you can get rid of the
just go back through everything and draw just a little bit deeper, or like write it just a little bit darker. And notice under the labs, the yours is the one that comes out really light. So when I read it, some spots I can read, some spots I can't.
And I use
I think I'm not sure if there are other people that use pencil or what, but I don't know. Yours just comes out lighter. So yeah, if you just want to write it darker or go over it like that, whichever. That would be appreciated, especially on something like this where you've got a lot going on more than that.
You remind me of the graph calculator because I keep looking at wrong information.
Yeah, so there's a graph calculator up here. Are they just copying these and putting them into Google like a standard?
Just, okay.
Okay, I'm not sure if I'm putting it
I just had my put it some.
And so now, the M cancels out G. So A is equal to that times G. Okay.
I did something wrong. I mean, I don't know what it is. I don't know. I'm so close. I literally just need to and I get the answer, but I got this. But I heard that the answer is 0.5 whatever. I got 1.55.
You're right.
No, yeah, right. It's probably you guys. I'm just saying.
Write this down to so that I can just get. I would keep it a couple decimal places out.
Because it's
This girl.
So I would think so. Make sure you have your units. And no, the M should be gone. Right, you canceled out the M's. You canceled these two
That's
here. You have to
probably why.
cancel the other side.
They're together, huh?
Is that all you have?
Yeah. Well, that's okay. Did I forget?
It'll be a matrix. Okay,
No, we
what
can
do you
just.
mean?
This is.
What is the units of G?
Oh, mine is in here.
It will be meters per second.
That's all I ended up with.
So.
No, that's times. Sorry. And mine is going to be a negative answer because of where I put it, so.
Oh, you're doing it the same way he's doing it.
Yeah, that's the way I think.
Right.
Literally, right? We're like probably like the 2 out of 3 people that actually decide. I think better. Yeah, I think better that way.
You know, there's an explanation for that.
Why?
I've taken a course where I studied grammar, which is a study of writing.
I did this.
And when you look at a paper, you point which way do you write?
I write with my right hand.
Or like which direction?
This is literally how I write, and I've always wanted to write. Why do I write with my paper sideways and I write this way? I don't know why, but ever since
But
I write this way.
from left to right, going right.
Yeah.
So that means right is the future, left is the past.
So.
Wait, what's that? Where?
Also, which way do we write? Up to down or down to up?
X-axis,
So up would be
So your
axis,
acceleration
down would be
opposite the source of
this
that
way.
motion. And
So
so
right, more to
you
the
wouldn't
right,
have to solve for X and
you're going to thinking about the future, whereas if it's more back.
Yeah,
If you're thinking backwards, or like you're thinking in the
I have
past,
friends who think backwards. I know.
you're drawing from past to up.
All right. Okay, there we go.
I don't understand. You have to change.